Okay, in this video we're looking at the sine rule, and this will be our first rule for non-right angled triangles. So previously we had SOHCAHTOA for right angled triangles. That was when you had two sides and an angle, and you had 1 out of 3 of those things missing. 1 out of 3. The sine rule works on any triangles, and it's about having 2 sides and 2 angles, and 1 out of 4 of those things are missing. So you're finding the fourth one, whatever that is. Now, previously we'd labeled triangles with opposite, adjacent, and hypotenuse. Now we're labeling them a bit differently. So you just call the 3 angles, so even you could call it inside the triangle, like A, B, and C, the capital versions. Then across from B is little b, across from big A is little a, and across from big C is little c. So that's how we label non-right angled triangles. So speaking of this one, we would call this side across here little a because it's across from the angle big A, and we'd call this side little b and this side little c. So really importantly, the angles are the capital letters, the sides are the lowercase letters. Okay, so we're trying to find the length of AC. So what we want is actually that little b, because that's sort of the line from A to C there. And we've got 3 other things. So we need to use one version of the sine rule. We don't really care about this A or this A because it's not an angle or length we have, and it's not something we're looking for either. So the sine rule normally looks like this. A over sine A equals B over sine B equals C over sine C. Now it looks a bit weird because it's got 2 equal signs. Because we don't care about A, we're getting rid of that bit of the sine rule. So we're just left with this thing. And now we can just plug in everything we have. So I don't know what B is, but I do know what all the other things are. So sine of big B is 58. And then we've got C, so little c is 21. And then we've got sine of 39 for that other bit. So that's how we apply the sine rule. You're just plugging in what all those things are. And to get B on its own, you've got to times by sine 58. So 21 over sine 39 times sine of 58, just like that. Cool. All right, now we can see what we get. So if we do that, just make sure your calculator is still in degrees. So in the menu, you've got to be measuring the angle in degrees. We're going to put in all those bits that we got. 21 on the top, sine of 39 on the bottom, times, and then sine of 58 on the top. 28.3. That's to 3 significant figures, 28.3, and it's a length, so centimeters. There we go. And since the question was asking for AC in particular, so therefore AC is 28.3 centimeters. That's what it is. Okay, so there's 2 versions of the sine rule. We use the version with the links on the top if we are finding a length. That's the version I just used then. If we're wanting the angle, we use the version with the angles on top, finding the angle. Now, if you pick the wrong one, it will still work. It's just it's going to be a bit nastier with the algebra. So try and use those. Okay, find, and that's a lot of words. First of all, let's draw up triangle ABC. It's going to be a triangle there. They want to find the angle ACB. So it's the angle which starts at A, goes out to C, and then goes out to B, like that. So this angle in here, I'll call theta. Let angle ACB equal theta. Theta is what we're trying to find. Okay, if AC is 14, so we've got this length here is 14 centimeters. AB is 22, so this length here is 22 centimeters, and angle ABC is 25. So angle ABC is going to look like A to B to C, so that angle there is 25 degrees. Now let's use the sine rule. So what we should really do is label little a across from here, little b across from big B, and little c across from big C, and then we figure out which side we don't want. Again, it's actually A that we don't care about, so only B and C. So we're going to use this version of the sine rule. Sine B over B is sine C over C. We don't care about a in this example. Okay, now let's put in everything we have. So this is sine of 25, that's the b value. The little b value is 14. And then we have sine of theta over 22. So first of all, I'm actually going to swap the order of that. Times by 22. I guess if I'm timesing by 22, it would look like that, not that it really matters. And then theta, we have to inverse sine both sides together. So it's going to be inverse sine 22 times sine of 25 all over 14. So that's how we apply that formula there. If you want inverse sine on your calculator, it's under shift sine, and then we can put in what all those things are. So 22, make sure you open a bracket, 22 times sine of 25 all over 14. Close your bracket off, and then that should give us an approximate 41.6. Theta roughly equals 41.6 degrees. Okay, so we've got that theta there, 41.6 degrees. So that is really good. All right, now I wish that was just the final answer, but there's actually two answers here. So this, what we were trying to do here, I guess is like a little middle step before we figured that out. If we work out the stuff inside the sine there, theta had to be inverse sine of all that stuff. Now the stuff inside there is 0.664. So it's inverse sine of 0.664. And what we figured out is that if we do sine of 41.6, we'll see what we get. So sine of 41.6 does give us essentially 0.664, apart from like a little rounding error there. But the weird thing is, sine of 138.4 also gives us that same number. Now, how did I know 138.4? That is 180 take 41.6. If you work that out, it's 138.4. So there's two answers here. 138.4 degrees. Both answers are valid. So the triangle could look like two things. It could look like this, so 25, 22, let's see, 14 and 41.6. Or it could look a bit more like this. So let's see, make sure I get this right. 138.4, but that's still 14 and that's still 22 and that's still 25. So there's actually two solutions for the sine rule when you're finding an angle. And the way that you get the other solution is just 180 take the original solution. The other thing just to make a note of is if this angle here was too big, then we might not have had this solution if the angles were going to add up to be more than 180 in the triangle. So you just check that as well. A little bit weird that you get two answers from the sine rule, but it's kind of like when you take a square root of a number, you get two answers. You get the plus version and the minus version. In this one, you get the normal angle and then 180 minus the normal angle.